All right, welcome back, everyone. So far, do we have any questions? So far, do we have any questions before we move on to loops? Okay, I am assuming no questions. All right, so the last topic for this week is loops. Loops, so for loops, you're trying to iterate over, how best can I explain this? You're trying to carry out a particular function multiple times without actually, okay, you're trying to carry out a particular function multiple times, right? Let me just say in a stress-free way, without, let's say, actually, okay, let me just show you. Let me just show you, so that you understand what I mean when I say without actually writing it down. Because you write it down, but not in the conventional way. So for the conventional way, I want to write hello world 10 times. For the conventional way, I want to write hello world 10 times. This is what I'll do. Hello world, come to the right line, hello world, come to the right line, hello world. Once I have it 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is hello world 10 times. Let me run this. Can you all see my screen?
Yes, we can.
Okay, great. So, great, thank you. Before we went on break, we had 17 persons or 16 persons on this call. Right now, we have just 8. Can someone just text them that they can come back on the call, probably on WhatsApp? I think that's where most of them are. All right, so this is hello world 10 times. But what if I wanted to write hello world, or not even hello world? What if I wanted to carry out an action like 1,000 times? Do you think it would be wise for me to now start typing it out? Well, that is where loops comes in, right? So for loops, you can now decide to carry out an action multiple times. And there are 3 types of loops. There is a for loop, there is a while loop, and there is a do while loop. We're going to be touching them on this call. So for the for loop, you want to type for, and inside of your brackets, you create a bracket. Inside of your brackets, you create a variable and instantiate that variable with your starting point. So you have a starting point. Then you now define an ending point for your variable. So you have an ending point. Then finally, you define the steps you need to take, right? So steps. Then inside of this block, you now define the action you want to carry out.
There is an error in the starting spelling.
Yeah, don't worry. This is just like, this is not what we're going to be using. It's just like something I'm using to show you, okay, this is what you should do. So I'm going to clean it up right now. So a starting point, an ending point, and the steps, then inside your action. Now, so for a starting point, I could say int I equals 0. right? And most times you probably have heard the joke that programming guys like counting from 0. And that is true because most times in coding, most things start their count from 0. So even when you're creating your loops, most times you want to start from 0. You can start from 5, you can start from 10, you can start from anywhere, but most times you start from 0. Now, because I'm starting from 0, my ending point will be lesser than 10. I want 10 times, but because I'm starting from 0, my ending point will be lesser than 10. Now, the steps will now be, how many steps will I be taking inside? So in this scenario, I would say I equals I plus 1. So what that means is I is 0 now. I will check if I is lesser than 10. Then if it's lesser than 10, I will add 1 to I. So I will now be 1. Then I'll come inside this block and carry out my action. I'll come back out. Remember, I is now 1. I'll check if I is lesser than 10. 1 is lesser than 10. I'll come here and add 1 to I. I will be 2, right? Then I'll come inside there, carry out the action. I'll come back out and check if 2 is lesser than 10. If it's lesser than 10, I'll come here and add 1 to it. Then I'll come back here, I will be 3. I'll come back here to the action and continue like that until I get to 9. 9 is lesser than 10. I'll add 1 to I will be 10, and I'll do this action. Then when I come back out, 10 is not lesser than 10. Then just jump out of this block and go to the next statement. So let's see that in action. Console the right line. So let me even, instead of print hello world, let me print I. Let me print the variable I so that you see what's going to happen. For some reason, my system is freezing up. I'm not sure why. But let's print this. So can you see that? For the first iteration, we call it iteration, and that's why most times when people are creating loops, a loop is the only place that you're not actually typing the name of your variables, like the way I've been typing stuff from user, score, and the rest. A loop is the only place that most people just use I, and that's because it's kind of short for iteration, right? So for the first iteration, it prints 0, then it adds 1, prints 1, and then when it gets to 9, it stops there. So it's the same thing if I decide to just say print hello world. So now print hello world 10 times. So let's see that in action. I'm going to print hello world 10 times. This is it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is just from printing it once here and telling the loop to print it 10 times. So what if I want to print it 100 times? It's going to do the same thing. And I don't have to type hello world 100 times. And that is the power of loops, right? You can carry out an action multiple times without actually printing multiple times. It's still printing. And it has stopped. And if I count from trying to go up, and if I count from here down to here, that is hello world 100 times. Now, most times when you're creating a loop, you're not going to be just printing it 100 times or 1 million times or whatever. There are purposes of writing a loop, right? So let me give an instance. I want to look for, so someone is telling me to write a code where, I don't know if this is part of your task, I'm not sure. It's part. I'm not sure. So someone is telling me, oh, write a code where you're getting all the even numbers between 0 and the number I am giving you. So let's say you ask me, give me a number, and I give you 100. I want you to print all the even numbers between 0 and 100. Then the next time I give you 50, I want you to print all the even numbers between 0 and 50. The next time I give you 1 million, I want you to print all the even numbers between 0 and 1 million. What do you do? Now, what I want to do is, let me get this question again. Give me a number should be my statement. I'm just going to change this to number. All right. So in this case, I can pass in number here because number is an integer, right? And I would say lesser than or equal to lesser than or equal to number. The system is freezing up. Okay. So why am I passing number into this place? It's because what the statements or what the logic they are asking me for is they want me to print the number of even numbers or all the even numbers between 0 and whatever number they are giving me. So I don't know the number that they're going to be given to me. The number is unknown. So that number is what I want to put here. So whatever the number they want to give me is what I will put here. So, and I will look through from 0 to that number to get all the even numbers. Now, how do I get all the even numbers? I'll do a conditional that says, so I'm guessing for every iteration, right? So for 0, I'll check if 0 is an even number. For 1, I'll check if 1 is an even number. For 2, I'll do that. So what I want to do is int if I, which is the iteration, then modulus. I'm pretty sure we talked about modulus previously. I modulus 2 is equal to 0. Remember what modulus is, right? Who can remind us what modulus is or what modulus does?
Percentage.
Yeah, basically, modulus is just a form of division whereby your remainder is returned. I don't know.
Yes, that's correct, right? So modulus is an operator, it's an arithmetic operator that returns just the remainder. Every other thing before it or after it doesn't concern, it just returns the remainder. And remember, even numbers, the definition of even number is a number that if you divide it by 2, has no remainder. And that's what I did here. So if I divide whatever number here by 2 and the remainder is 0, then that is an even number. If the remainder is not 0, then that number is probably an odd number or whatever. So I'm going to leave it as even number. Then I'm going to say, let me do I, which is a variable, plus, this is concatenation. We also talked about concatenation, is an even number. Concatenation is where I am creating a sentence from both a variable and a string or 2 strings or something. Just adding the plus sign is concatenating whatever is here to whatever is here. And then if I now run this, it's going to print all of the even numbers between our calculations. So let me just pick a quicker one first. I'm going to pick 10. So you see 0 is an even number, 2 is an even number, 4 is an even number, 6 is an even number, 8 is an even number, 10 is an even number. And then once it gets to like 1 modulus 2 would be 1. So it's not an even number. When it gets to 3, the same thing. And that is how it works. So if I even go as high as, let's say 50, it's going to continue because then I'm passing the value here and that it will now show it. As you can see here, 0 to 50. Now, quick question, is 0 an even number? Mathematicians in the house. I think from the
Yes,
definition
it's
it's
a
an
very perfect even number. It's the most perfect even number so far.
Really?
Yes.
Everywhere.
All right, so I think from the definition, it's an even number. Now, someone wants to make this a bit, tougher for us. Now the command is saying, okay, let me even write the command down because I'm going to drop this code. So print out all the even numbers between 0 and any number given by the user. Okay, so that's the first command. And the second command is do not print any even number between 10 and 20. So in case the person gives you, let me see, more than 10, right? They don't want you to print any number between 10 and 20. How can we do that? So there are two statements in loops. One is called, it's even in, we've already used one of them, break. Break, as we already know, just jumps out of the code. Then there's the other one called continue. What continue does is it ignores that statement. So what I want to do is, if I is greater than or equal to 10, or I is lesser than or equal to 20, I'm just going to type continue. So once it gets here, it's going to just jump out. It's going to ignore all of these other ones and jump out and go back. So let's see this in action. Now, if I put in 10, wow. Okay. Yeah. Okay, so what happened here is, because of this lesser than or equal to 20, it just continued everything. Okay, so that's going to be a problem. So now this is where a logic is affecting another logic, and I have to figure out a way of ignoring this logic without really ignoring the logic. Okay, so what do I do now? Between 10 and 20. Okay, so now instead of or, I'm going to use and. That's a better way. So it has to be between 10 and 20, not or 20. And this is going to now make it work perfect. It has to be between 10 and 20. So if it's not between 10 and 20, it's going to have an issue. Good. So you see that once it goes to 10, previously, I think previously it was printing 10, right? Yeah, it was printing 10 previously. But now it's no longer printing 10. Sorry about that. Now, if I put in 15, it's still going to stop at 8. By putting 30, it's going to ignore 10 and 20, and then jump to 22. Can you see that? 0, 2, 4, 6, 8, 22, 24, 26, 28, 30. So what this did is it made us ignore whatever is between 10 and 20. And that is what this logic is doing. And all we can do is using the continue statement. Now, they want to make it a bit tougher, and they say if the user imputes a value more than 50, ignore the numbers higher than 50, right? So now they said, okay, now we've ignored 10 and 20, but somebody might just be, mean, and they want to overpower our load, and then without passing 1 billion, 10 million, 1 million, so that our code is start frame. So we want to ignore a value more than 50. What do we do? What we do in this case is I'll pass in another if statement, or just use else if I is greater than 50, then what do I want to do here? Instead of continue, this time I'm going to use break. I can use continue and it would work, because if I use continue, it's going to ignore the rest and come back. It's going to ignore the rest and come back. But what would happen is it will still go through the whole loop if I use continue. It will still go through if the person puts 1 million, it's still going to go through the whole loop 1 million times. If the person puts 1 billion, if integer will not be able to hold a value of 1 billion, but I think if this was a long, it will go through the loop 1 billion times. So to avoid that, what break will do is just breaks out of this loop immediately. So it's not going to go through the loop for more than 50 times. And what we would have done is to debug it so that we can see. I'll see if I can debug it. The last time the debugger was not working. I'll see if I can debug it. So let me put 50. It's run to 50. Now I'm going to close it, and let me put 10,000. We're going to stop at 50, right? So let's see if our debugger would work. So I'm going to comment all of this out. But before I comment it out, I'm going to comment all of this out. I want to try something with our debugger. So I'm going to say 10, lesser than or equal to 10. Then I'm going to remove this, and I'm going to say if I is greater than 5, break, right? Okay, so let's run our debugger. I'm going to put my breakpoints here. So want to run our debugger and go through our loop to see how many times to go through. So our debugger is coming up. Okay, great. So now if you look at this point, it says int I is 0. I'm going to step in. I is now 1, right? I'm going to go in. I is now 2. 2 is not greater than 5. That's why it's just jumping out. I'm going to the next one. I is now 3. 3 is not greater than 5. I is now 4. 4 is not greater than 5. I is now 5. 5 is also not greater than 5. Now watch what is going to happen now. I is now 6. 6 is greater than 5, and it went into it. You see? went into it, and then if it breaks, just going to break out of the loop and goes to the end. It's going to ignore the rest parts. It's going to break out of it. And that's the end of our code. Now, what if I pass in, instead of break, I put in continue. It's going to run through the code all times, but once, let me do this now, console.write line I. So let's debug this again. So you see what's going to happen, what the difference is between break and continue. The difference between break and continue just jumps to the next iteration. Break just jumps out of the block totally, forgetting that there's any other thing to be done. And that is why, in this case, I'm not going to use continue, because if I use continue, whatever I'm trying to avoid, in the interface or whatever your results, what you're saying would definitely be what you want, but you're still going to stress your code to go through the iteration if it's continue. Let's see this happen. So I'm now going through the print I, which is 0 down here, right? Print I 1, print I 2, print I 3, print I 4, print I 5. Now watch at this point, because I would be 6 now, and it's going to go into the code. It's going to click on continue, and then it's going to jump back to the beginning. I is now 7. It's going to continue the loop. It's not going to do anything, just going to keep continuing the loop and still stressing your machine, still trying to run this loop. But then you don't need anything again. So it depends on your logic, depends on what you are trying to implement. Then you now know what to use between break and continue. Wow, our time is exhausted again. And I wanted us to touch on the while loop and do while loop. Do you guys want to research on the while loop and do while loop yourselves? Or should we carry out one more video to touch on it? Okay, so one person said they will research on it, but we have 8 persons here, so I want more answers.
Hello, Mr. Emmanuel.
Yes, please.
Yes, I will suggest we finish everything tonight. So for those who can do the research, they can do the research, but we can still come back and finish the code tonight. And we can share the sample code with others so that as they are doing research, they can check the code.
Okay. Actually, we've already touched on the most complicated part of loops. So for while loop and do while loop, it's just going to be, I'm just going to need to explain the syntax and why you're using each, right? So let's see what we can cover before the end of this. So for while loop, remember that for loop, this is the condition, but for while loop, all we need is while. So for while loop, I'm going to comment this out. Remember the starting point. For while loop, the starting point would be outside. Int I is equal to 0. The condition will be in here. I is lesser than 10. Then your console.write line. I'm just going to print I so that you're not taking much time. Then your step will now be I++ before you finish. And that is how you write a while loop. So let's test this out to see that it's just a different way of writing it, right? For loop, you put all of the conditions here, and you can see it's printing all of this here. And that is how you write a while loop, right? Then for do while loop. So the difference between while loop, for loop, and do while loop is for loop and while loop. Depending on your condition, it could just ignore, let me go back. It could ignore it totally. So let's say I is lesser than -1, and I try to run it. It can ignore it totally and not even print anything because the condition is a false condition. Can you see that, right? Then the same thing can happen in a for loop. Let me show you. If I is equal to lesser than or equal to -1, it would ignore the whatever is inside totally and nothing would happen. And that's the difference between for loop, while loop, and do while loop. For do while loop, it would run at least once, right? So even if the condition is false, it will run at least once. So there are scenarios where you want your loop to run at least once before checking the condition. And that is how, this is how to carry out a do while loop. It's almost similar to a while loop because the condition will be, the starting point will be outside, int I equals 0. Now you have do, right? So I just did, I pressed tab to show the shortcut, but let me just type it out. Do, then you put your action. So I'm just going to say console, the right line, I. Then outside of it, you now say while, you put your condition. So while I is lesser than 5. So I'm going to say while I is lesser than 5 first. And when I do .NET run, it's going to print this, check, oh wait, I need to put a condition. I++. Remember, I++ is more or less the same as I equals I plus 1, right? So syntactic sugar, or a shorter way of writing it from what we touched, I think in our 2. Oh yeah, I need to put a semicolon here, sorry. So now let's run it again. Great. So it's going to do this, add to this one before checking the condition. And that's the difference between while loop and do while loop. It checks the condition after printing. So now let's say I, the same thing I did, I lesser than -1. It's going to at least print once. And it's going to print 0 before checking the condition and saying that, oh, it's not, you see that it's not a true condition. So there are scenarios where you want it to print at least once before doing whatever you want to do. And that is when you need a do while loop. So that is just the situation between while loop and this thing. But you can do all of these other things, this condition that we did earlier, in a while loop and a do while loop, in case you want to do any of these conditions. But this is how you write a while loop. And this is how you write a do while loop. So I just remember that I could just explain it quickly without starting a new video. Then you can now research more on it and ask any questions during the week if you have any questions, so that I don't need to now upload a third video. Just part 1 and 2 is fine. All right, so do we have any questions? We have less than 3 minutes. Do we have any questions? I'm going to share the code, don't worry, so that you can go through it while you're researching. Any questions? No questions? All right then. Thank you very much, everyone, for making our time, even though it's this late. Thank you very much for making our time. And let's see how it goes throughout the week. I'll drop the link for submitting the tasks for those who have started submitting the tasks. And then I'll also try and go through your tasks for week 1 and 2 tomorrow, and then give you feedback by the end of the day tomorrow. Have a nice evening and weekend. The weekend is over, so have a nice evening, and tomorrow have a nice day. Good night.
Yeah, good night.